In this video, we're going to talk about strategies for verifying trigonometric identities. All right, and the book offers some really good advice or tips for verifying identities. So first off, it's going to be really good for you to learn the fundamental identities. We talked about in the last video the possibility of committing these to memory, right? Because you really want to kind of have them at the ready so that you don't have to look them up every time. Another good tip is to try to rewrite the more complicated side. So this time we're going to work up to it, but we're going to be working with an equation, which means we're going to have a left side and a right side, and we're going to try to prove that they're equal to each other. So sometimes it's easier to start with the more complicated side. We talked about in the last video expressing everything in sines and cosines. Sometimes that makes it a little more clear as to how you can manipulate things. So that's a good strategy. We can use algebra and factoring when we need it. We can do some substitution if we need it. And the last one here is talking about multiplying by a conjugate. So I wanted to kind of demonstrate that to you because that may not on its own make a lot of sense. So to do that, I'm actually going to show you two things, right? So remember, one of the Pythagorean identities is cosine squared plus sine squared equals 1. Another way to write that, we could take this and rearrange it and still use it, right? So one way to rearrange it would be to subtract the sine squared over to the other side. So let's do that. So then cosine squared would be equal to 1 minus sine squared. So it's still the same identity, but we're just kind of using it in a different form. And that's definitely something that's going to come up, something that's worth thinking about. All right, so now let's go back to this idea of the conjugate. A conjugate is something, and this shows up in a lot of different places in algebra, where the sign in the middle is different. So one with a plus, one with a minus, they're conjugates of each other. And the reason why that's so convenient is usually that brings up a special result when we multiply two conjugates together. So let's do that here. I'm going to squeeze it in. I'm sorry, I should have left myself a little more space. All right, so if we FOIL these together, we'll have 1. On the outside, we'll have minus sine theta. On the inside, we'll have plus sine of theta. And then the last times the last will give us a minus sine squared theta. Right, so the minus sine of theta and the plus sine of theta, they have opposite signs, so they'll add to 0 and cancel each other out. And because I'm out of space, I'm going to have to go up. Okay, so really what we're left with is 1 minus sine squared of theta. And we have an identity for that, right? And that's kind of where I was going with that. So this is the same as cosine squared of theta. All right, so that's kind of why sometimes that's useful. And so if we see an expression like that, a lot of times, if we can't figure out how to simplify it on its own, we might be able to use a conjugate. Okay, so we'll come back to that when we need to. This, I think, is really important. It's a really, really good strategy to just work with one side of the equation and rewrite it to match the other side, and use that method to prove that the two sides are equal. So we'll do that with all of our examples, and I want to encourage you to try and do that as well. Before we actually verify an identity, I thought we'd start with just some more simplifying, where we're trying to make it as simple as possible. We don't have a right-hand side. We don't have an equal sign. We're just trying to do what we can to make it simple. Okay, and this one, I think this one would be a really good one to use algebra for. So when I'm talking about algebra, I'm thinking about FOILing this out, right? So let's start with that. So let's just write out 2 copies of this. For the moment, we're just going to let this minus 2 times the tangent of theta kind of hang out in the back, right? If we FOIL this, we'll have 1. On the outside, we'll have plus tangent of theta. On the inside, we'll have plus tangent of theta. So that's plus 2 times the tangent of theta. And then the last times the last would be a plus tangent squared. Okay, and lo and behold, the positive 2 tangent of theta and the negative 2 tangent of theta, those are going to add to 0, cancel out. So we'll end up with 1 plus tangent squared of theta. That looks like a Pythagorean identity. So if I go back to my cheat sheet, I realize, yes, it is. So this is equal to the secant squared of theta. Okay, so sometimes just using algebra, multiplying things out, distributing, sometimes that is enough to help us simplify. Let's try another one. This is sort of the opposite. We can also take that idea in reverse and try to factor. Right? This looks like something that's kind of in quadratic form. We usually say that things are in quadratic form if the exponent in the front term is double of the middle. And that's what we have here, right? So we could factor this. To get cosine raised to the 4th power, I would need cosine squared. Sorry, my cat is attacking me. And to get 1 in the back, I'm going to need 1 and 1. So if I FOIL that together, cosine squared times cosine squared would be cosine to the 4th. And then on the outside, I would need a minus cosine squared. And on the inside, I would need a minus cosine squared to get the middle. And negative 1 times negative 1 would be 1. Okay, so then we want to think about another Pythagorean identity, right? Let's see, it doesn't actually look like this, though. It looks reversed. And so I can reverse this. Well, actually, on second thought. All right, let me write out what I'm thinking off to the side so you don't have to read my mind. Right, so I'm thinking about, actually it looks like this, cosine squared plus sine squared equals 1. So how can I take this and make it useful for this expression? So I could move the sine squared over to the right, and I could move the 1 over to the left, right? So I could do cosine squared of theta minus 1. Subtracted the 1 over, and I could subtract the sine squared over to the right hand side. And that's kind of what I needed, right? I have cosine squared minus 1, so both of these are equal to negative sine squared of theta. This one also. And if I multiply them together, the negative times the negative is going to be a positive, and I'm going to end up with sine to the 4th theta. Okay, so I think both of those gave you good examples of where algebra can come into play. That was kind of my goal for choosing those 2. Now let's take a few minutes to try to verify some identities. So this one's also from your book. We want to show that sine squared of beta multiplied by 1 plus the cotangent squared of beta is equal to 1. Okay, I think you could do this several different ways. I'm not sure which way would be the best, okay, and I don't really think that there's any advantage, honestly, one or the other. We could distribute the sign. That's usually my first thought. But now that I'm looking at this, 1 plus the cotangent, that's a Pythagorean identity, right? So if you look at your cheat sheet, the Pythagorean identity, actually, I'm going to write down the left-hand side, because just like we said earlier, that's the more complicated side. And so I'm going to just work with the left-hand side and use identities until I get to the right-hand side. So if I use my cheat sheet, 1 plus the cotangent of theta is the cosecant squared of theta. And I'll go ahead and spell this out really well. So, oops, sorry, that should be a beta. Remember, the cosecant is 1 over the sine. Give this as over 1 if you need to. So sine squared divided by sine squared, they're going to divide out to be 1. And that's what we were trying to prove, that it equals to 1. So we've done it. We've verified the identity. We proved that they're equal. Let's try another one. How about the cotangent plus the tangent is equal to the secant times the cosecant? So you can pick a side you want to start with. I'm going to start with the left-hand side again. So I'm going to just jot that down. So cotangent of theta plus tangent of theta. I don't have an identity that adds these two, right? I do have the reciprocal identity. Maybe you could make that work. My first thought was to use sines and cosines, so I'm going to start with that. The cotangent is the cosine of theta over the sine of theta. And the tangent is the opposite, so the sine of theta over the cosine of theta. Since these are fractions, it might be good to get a common denominator. So I'm going to do that. I'm going to multiply top and bottom by cosine of theta for the first fraction. And I'm going to multiply top and bottom of the second fraction by sine of theta. That's going to give me that common denominator. And now, actually, can I go ahead and combine these into one fraction? Since they're the same denominator, I'm going to have cosine squared theta plus sine squared theta over my common denominator of sine theta times cosine theta. Okay, and here's where the identities come in, right? I have that cosine squared plus sine squared is 1. I'm using that Pythagorean identity again. Sorry. Okay. I have it written as one fraction right now, but we could definitely break it up into two separate fractions, right? 1 over the sine. Actually, I'm shooting for this, so let's do 1 over the cosine. They're multiplied, so I can switch the order. 1 over the cosine would be the secant of theta, and 1 over the sine would be the cosecant of theta. So I've done it. verified that those two are equal to each other. I hope as you are watching these that you are kind of thinking along with me. They do take some creative abilities, and there's definitely not always one route to take. So if you see something else, I highly recommend pause the video, pursue it, see if you can get to the same end as I did, right? We may not think about these in the exact same way, and that's completely fine. I think I've got one more. Let's try this one. Again, you want to pick a side to start with. And like I said, there's not really one right answer. I'm going to choose the left-hand side because I really want to show you a method that we mentioned earlier. So to divide, sometimes with complex numbers and with radicals, it's very common to use that conjugate idea to divide. So I think it might be useful to do that here. So let's try it. So what we'll do is we'll take this fraction that we have and we'll multiply by the conjugate of the denominator. So the conjugate of the denominator would be 1 minus cosine of x. And so we'll multiply the top and the bottom by 1 minus cosine of x. We are allowed to do that because as long as I multiply both the top and the bottom, it's sort of like multiplying by 1. I'm not changing the value, I'm just changing what the expression looks like, but I could definitely factor and reduce and get back to the original so they're equal. Okay, so let's FOIL the top and FOIL the bottom. So in the top, we're going to have 1. On the outside, we'll have minus cosine x. And on the inside, we'll have minus cosine x. So that's minus 2 cosine x. Then the last times the last would be a plus cosine squared x. On the bottom, we'll have 1. I'm going to go ahead and write this out. Minus cosine x plus cosine x minus cosine squared x. And because the middle terms are equal and opposite, they're going to add to 0 and cancel out. So now I'm going to have the same numerator over 1 minus cosine squared x. This is where that Pythagorean identity comes in. Usually it's cosine squared plus sine squared equals 1. But if I subtract the cosine squared over to the other side, this whole thing is equal to sine squared of x. We've drawn that out a couple times, so I'm not going to draw it out this time. Okay, so let me pull this down. This is our goal. Can you start to see where the cotangent and the cosecant, where that's going to come from? All right, so let's put that in here. I think we may have to rearrange a little bit, but let's go ahead and start forming the cosecant and the cotangent. So all of these parts in the top are going to be divided by sine squared, so we could split them up, right? As 1 over sine squared would be the cosecant squared minus 2 times, maybe we should leave this, yeah, Let's write this as cosine of x over sine squared for right now. I'll come back to that in a second. And then cosine squared over sine squared, that's definitely the cotangent squared. Okay. Again, I'm going to scroll back up to the top for a second. Notice the cotangent comes first. So I'm going to swap these two. I can do that because they're both positive. I'm not really changing any signs or anything like that. So I'm going to write the cotangent squared first. We'd really like this middle term to have both the cotangent and the cosecant, because I have a feeling we're going to be doing some factoring in a second. So I'm going to write it out in several steps just so that you can see what I'm getting, where I'm getting it from. Let's take one of those signs and make it into a fraction with a cosine. That's going to be the cotangent. But we still have one more sign, so let's make it 1 over the sine. 1 over the sine would be the cosecant. Okay, so really what I have is cotangent squared minus 2 times cotangent of x times the cosecant of x, plus, remember I moved that cosecant to the back. Okay, but our final answer is factored, and so we really need to factor this. Right, to get cotangent squared, I need the cotangent of x in the front of both parentheses. To get the cosecant squared, I really need the cosecant in the back of each parentheses. And then in the middle, I'm going to have the cotangent times the cosecant, but I need a negative. And then same thing here. And so that'll go together to make 2 in the middle. Since they're the same, I can write them as the cotangent of x minus the cosecant of x squared. And this problem went a little long, but if I scroll all the way back up to the top, that's what I was trying to prove. Right? So we're good. All right, I hope that these examples will kind of do you well as far as showing you the process and some of the creativity and just some of the different tips and techniques that you can use to verify identities. This is definitely something that's going to take some practice. I think you have an assignment that you can use to practice this with, and if you need extra practice, there's always problems in the textbook that you can try this out on. All right, well, good luck. We'll see you in the next video.